So, good evening. Thank you for staying at the last session, and I'll try to get you to the happy hour, but hopefully you'll find something useful between now and then. So during this session, I'll give you a quick overview of Java Management Service, which we started offering in 2021. Now, a common question that I get when I talk about Java Management Service is, why would I need to manage Java Runtimes? What's wrong if something is already running? Why do I want to update them? Just, it's running. Don't rock the boat. Well, there's a good reason why you'd like to update your Java runtime. A running Java application is the result of the collaboration between different components. You have the developer code, which is what everybody thinks of as the application, right? And rightly so, that's where all your business logic is, all that stuff that's unique to you. But developers, nobody writes everything now. You use some third-party libraries, and they'll be updated whenever the vendor wants to update them. And there is also the Java runtime itself, which at a high level is comprised, wait a minute, where's the, there we go, sorry. Which at a high level is comprised of the Java runtime and the JDK libraries. Now, the JDK libraries free developers from having to do a lot of common tasks, and they provide a unified base of features that all support, that will make Java work the same in all supported platforms. Now, the developer code and the third-party libraries are under the control of the Java developer. So they can only be updated if the Java developer updates the application. The Java runtime, on the other hand, is updated by somebody like Oracle and lets the users update their application without actually changing the developer code. Now, this separation between the developer code and the runtime opens the door for some interesting opportunities. Now, if you attended my earlier session, you saw a slide like this, where we showed that we're releasing a new version of Java every 6 months. That's pretty clear. But then some of them have a very long line of support, and others not so much. So the LTS releases get at least 8 years of support. The non-LTS releases every 6 months. But what does that mean? Well, after every release is launched, we produced critical patch updates for every quarter, and it will be receiving updates for its whole lifetime. Now, the number of updates that any release will receive depends on whether it's LTS or not. So long-term support releases will get updates, as you see here in this page, for many years. That's 11, 17, and 21. The non-long-term support releases, it's only for 6 months. Now, this page in java.com, release matrices, lets you see in a very graphical way what the others slide showed. Now, let's imagine that we are today running a program running on 17.06. That's the most recent version of JDK 17. Now, when the release in April, as you can see, we have planned to release some critical patch updates for all supported releases. When that happens, Oracle being a contributor to open source, OpenJDK, we will put the source code for 20.01 in OpenJDK. And if there's any vulnerabilities that could apply to 17.06, then you probably want to patch that thing sooner rather than later, because somebody out there is going to start looking into, hey, what did they fix with 20.01, and could those fixes also impact 17.06? Well, you will, when that happens, you have two choices. You can update to the next version of 17. So we call that updating your runtime. Or you can upgrade to a different version, cross to a new release family. Either of those two would be fine, right? Now, there are many users out there that when they see this little diagram, they think, oh, I'm going to update only about the security vulnerabilities that Aurelio just mentioned, right? So we come up with a list of vulnerabilities fixed on every release, and you're thinking, that's why I need to update, right? You'll run some scan of your systems, and it will flag 17.06 as being old, and you think, I need to update to avoid bad things happening to me. And that's true, and you should update for that. But let's also focus on the good things that happen when you update. It's not just to avoid bad things, right? So what's the good stuff that I get by applying these updates? So the real value is this one, right? Your programs work longer because you wrote them in Java. What do I mean with that? Well, remember those libraries that I mentioned? Those libraries get updated too. And what the libraries do get updated even in those releases. So most people think of the updates as a minor improvement in performance that maybe I can live without, right? It was working fine. But there's some improvements in the libraries that you really shouldn't live without. My favorite example is crypto algorithms. Now, here's some sample code. You're not supposed to try to understand it. But here's some sample code that could have been written in 2014, right, to securely read the content of https java.com using, at the time, SSL v3, which was the common encryption used for HTTPS. Now, around January of 2015, we disabled SSL v3, and we said you should now be using TLS. So here's the new code that you have to write to use TLS 1.0 or TLS 1.1. Can anybody spot the differences there? Let me help you out by highlighting them in red. There's no difference. It's the exact same code. So your application, as written to use SSL v3, now is running TLS 1.0. And sure enough, April of 2021, we disabled TLS 1.0 and TLS 1.1, and guess what? Now you have to update your code to use TLS 1.3. And this is what I meant, right? Your program, written in 2014, before there was a TLS 1.3, is now running with modern encryption and can continue to work even though you didn't change one line of code. Right? You didn't even have to recompile it. All you had to do was update the Java runtime. So this is one of the largest benefits of updating the Java runtimes. Now, what changes in these updates? Remember that I said you have two choices? Updates and upgrades. Well, with the updates within the same release family, we changed the minimum amount of stuff that is required to keep your application running. That includes those security vulnerability fixes, if there's any critical bug, time zone updates, some country changes when they do the daylight saving time, all of that that your program needs to continue having correctly, right? Sometimes the operating system changes something. If anybody here uses a Mac, they change their graphic engine so that instead of OpenSSL, they use Metal, and eventually they remove the old one, and will your program stop working? No, because you just keep updating your Java runtime, and Java takes care of that for you. As I said, we also disable some old encryption algorithms, we update root certificates, and we do some minor improvements. Now, the feature releases do all of that, plus new language features, new tools, some major changes to the JVM internals, and here's the catch. You cannot really move forward if you're carrying around an anchor, so you sometimes need to remove and deprecate old stuff that it's no longer as current. So we do take those out, and that makes then the choice a little different, right? Updating within the same release family, very low risk, right? It's going from 1706 to 1707 to 1708. You really shouldn't spend much time thinking about this one. You should just apply the patch. In the vast majority of cases, it'll just work. So my recommendation is we produce a CPU critical patch update. I know somebody else uses those acronyms for something else, but what do you want? We do it on the third Tuesday of January, April, July, and October. You should try to apply those patches almost as soon as possible on the same date. And only if it's mission critical, you should really bother testing first. For everybody else, try it out. And then if something blows up, you can always revert. Then I'd recommend take a look at the release notes. Chances are it's something simple, some change in some property, and you get it up and running again. If you do rollback, please do it only for the affected release. Don't do it for everybody. And it's not a license to just hold back forever. Figure out what's going on and update, because if you revert back, you're losing all of those updates. Upgrading to a different version, it's a little bit riskier. So I know some people want to do it all at the same time. My recommendation is do that when you're approaching the end of support of that version. So in 2022, we reached end of life of JDK 7. If you see that JDK 7 is approaching end of support and you intend to have your application running for longer, then it's probably a good time to move to a later version, right? Also, we do have some performance improvements that show up between releases. They don't impact every application, but if your application uses the new APIs or whatever, it might be worth updating. Sometimes there's a corporate mandate. Thou shalt use JDK 17 as of this date. You apply. And sometimes there's peer pressure. You don't want to come to the conferences and be the one raising your hand when people say, are you still using Java 8? Now, another thing that's different because of this separation between the runtime and the application is how you distribute and update your applications. So if you're writing an application, say, in C and compiling it to a native application, you'll grab your code, you'll compile it. In this case, I'm using a Windows compiler, and you get a Windows program. It's ready to run. You can just distribute it to your Windows users, and everybody can use it. And they're happy with it, and they use it, and they don't need anything special to run it. Now, if there's a new change to your application, the only way for your users to grab the new version, even if all you did was recompile it with a new library, is you got to distribute it again, make it get to all of your users. So there's no update that doesn't involve you and pushing everything to the developers. Java applications are a little different. If you compile a Java application, you don't get native code. You get bytecode. Now, bytecode, in one sense, it seems it's a little harder to use because it doesn't really run anywhere. You need to have your user get a Java virtual machine, a Java runtime, for the platform on which they want to run. But so if you have a Windows user, they'll have to get the Java runtime for Windows from Oracle, and now they can make this run. Now, there's one benefit to this, which is the same bytecode can be run by people in other platforms as long as they can find the Java runtime for those platforms. So that's good. Now, if you update the application like you did before, say there's a new version of your application, you still need to redistribute it and push the bytecode. But, and here's where it gets interesting, you can also update the Java runtime. So imagine this application was running with 1706. Without you changing anything and redistributing it, if we produce a 1707, your users can update their application to use new libraries, to use new improvements, without involving the developer. The developer could be somewhere else, like drinking the kitty by now. So, in order to really get your value out of your Java, your investment in Java, you need to understand then, you need to get an always up-to-date list of every Java runtime installed in every one of your systems. And it'd be great if we can highlight the ones that should be updated or upgraded, because the other ones you probably don't want to be using. You always need a list of which applications are used in each runtime, because one of the problems of having them separate is it is quite possible that you have a Java runtime that's not being used by anybody. I know I have been updated sometimes runtimes that I'm not using. Just, hey, there's a version of 11, I should update the next version of 11, without thinking, did I switch everything to 17? And I'm going to need a link between the two, right? Which one is using what? Now, using JMS, that's exactly what you will get, that complete list. Now, how do we do this? By relying on something called usage logging, which is available in the Oracle JDK. And here's how it works. If you look at the Oracle JDK, there's the description. You can turn on usage logging, and it will create a local record with a lot of useful information. The ones that are interesting for our case is I have the date and time, the name of the machine, what was I running on that machine, and the runtime location and the version. If I look into a server nowadays, I will find perhaps one Java runtime. More commonly, now that we have multiple versions, I could have different runtimes. I could have some application running on JDK 8, another one in 11, some in 17. There's a handful there running JDK 20 as of today. Then I'm going to be able to perhaps, if I have a good scanner, find all of my bytecode. But then I need usage tracker to, every time I use one of those, create a record that matches them and tells me what's using what. Then I have an agent grab that local file, encrypt it, and send it securely to the JMS server. And now, once it's all nicely collated, I can create my reports about what's going on each one of those machines. Now, what I just described, who can use it? Any Java user running on Windows or Linux. This works on desktops and servers. And you can run it for workloads on Oracle Cloud Infrastructure, on some third-party cloud, or on-premise, so your own machines, wherever you're running them. You will need to get an Oracle Cloud account, because you're going to have to log in and see all of these reports somewhere. Now, when you get that Oracle Cloud account, Oracle will give you 10 gigabytes of always free storage. In most cases, if you're using basic discovery, that should be plenty. JMS will save the data for about 6 months, I believe, and you will not need more than that. So you shouldn't have to pay for anything. Now, if you have a very large fleet, you may have to pay for extra storage, at which point you run into the cost of OCI, which is just a few cents per gigabytes per month. So this shouldn't be costly. JMS per se doesn't cost. So it's only the underlying storage that you may have to pay for. Now, all of what I've described right now, those are the basic discovery features. And they're available to everybody. We also have some advanced features. The advanced features do require that you are a customer. And by a customer, I mean either you have a universal subscription or one of our legacy subscription products, or you're running an OCI. Now, if you are in those use cases, you get the advanced features. What are the advanced features? Well, once I have an agent in the system, and since we know everything about the JVM, we can discover not only what applications you're running, but what's going on inside the application while it runs. So let's look into some of the stuff that you could get using these advanced features. First thing, I could find a Java server. So the basic discovery will tell me I'm running Tomcat. But it wouldn't tell you much more than that. If you have advanced features, you could go and get, OK, inside Tomcat, what it's running. Right? So you would not just get the list of Tomcat, Apache, or WebLogic. You will get, here's the versions that I'm running. And these are the applications running on those app servers. Another thing that you can get is we can figure out which Java libraries are being used by your application. So we can have JMS go and figure out, OK, this application is running. What libraries does it rely on? And it'll come up with a list, library 1, version X, library 2, version Y, et cetera, et cetera. Once we have that, we can compare those libraries and those versions against the NIST database to figure out if there are known vulnerabilities in any of those libraries and flag them for you. And let you know, OK, your Java runtime may be current, but you're using this old library in one of your applications, and you should really upgrade that as well. This is what JMS would look like. We will sort them by how dangerous the vulnerability in the library is, and then you can go and update your application with the latest version of the Java library. Okay? Here's one of my favorite ones, too. Remember that example that I showed about how your Java library could change the protocol that is being used to connect? That was pretty good, right? It also means your developer has no idea what protocol is being used. If you were to ask the original developer, they would say, well, SSL v3. And then it just flips underneath them. And it has to do not only with what's on your server, but what's on the machine that you're connecting to. So it's sometimes hard to tell what the library is up to. But you know who knows that? The JVM does, right? When we're running, we know what we're loading. So imagine then, here's our little crypto roadmap. It's a public page, java.com crypto roadmap, where we tell you when we're going to do things like disabling some algorithm or adding a new one. Without JMS, you could go configure your runtime to future, disable now what we will disable in the future, try it out, see if it blows up, and if it does, you know that you need to fix something. Or you could use JMS to do it for you. So here, it's not only what we've done we're going to do in the future, it's also what we've done in the past. Here's the example of the disabling of TLS 1.0 and 1.1 that I mentioned before. Notice that this was disabled in 2021, as I said, in April. But if you look on the change log, right, at the bottom, you see that we announced it on October of 2019. So in theory, you had several months on which you could have gone and say, oh, look, I'm using TLS 1.0. I should update it. Or when I apply the update in April of next year, this thing is going to blow up on me. How do you do that now? You tell JMS to do it. So you can tell JMS, sample these applications so that I know which cryptographic algorithms are being used, and then compare the result of that with the published crypto roadmap. And the beauty of it is, I will compare it with the then current crypto roadmap. If you run this report 2 days from now, when a new entry comes up, something that was OK might now be flagged as problematic. Right? Without this, most people discover that they were using something. When they apply the patch, it blows up. And then they have to go and configure and turn it back on or whatever. So this is one of my favorite features that I've wanted to do for a while. We can then tell you something that not even your developer knew, right? In the same vein, anybody here attended the flight recording session with Michael Witzet? I really wanted to attend that one, but it was at the same time as my session, so couldn't do that. If you run Flight Recorder, how does it work now? You have to go physically to the machine, or you have to remote to each individual machine. You have to turn it on. You have to wait for the recording to be done. Then you have to either analyze it on that machine if you have mission control there, or you have to transfer it to some other machine and analyze it. Right? And if you're looking at one machine or two, yeah, sure, no problem. But if you have a long fleet of machines and you want to do this, it's a bit of a pain. So using advanced features, I could ask JMS to turn on flight recording on any of the machines that I am managing for a particular application. It's not a blanket for everybody. You could say, this application, turn it on. I want to record for, 15 minutes. Once you have the sample, bring it up, get it out of that machine, and now it's in a centralized location. So it's a way of managing machines without having to go to each one of them and turn it on. Right? The current incarnation of these allows you to specify how long of a recording, when do I start, and we have different sets of possible flight recorder events that you could choose from, so that, oh, sorry, I gotta verify an update here. Glad that it didn't show up there. So, so you can decide which level of detail you wanna record. Now, keep an eye, by the way, all of this extra information is more data. So remember when I said that basic usage was probably gonna fit in 10 gigabytes? If you go a little crazy and start turning these all over the place, you could certainly go further out than 10 gigabytes. Right? But all of the data is collected in your object storage. You could decide to move it somewhere else and then clean that up. Or you could pay a very low price and just keep it there if you prefer it that way. Finally, the basic features tell you whether or not you have Java installed, what's it, and which version needs to be updated. But you're still on your own, and you better have some sort of software that will allow you to update the Java runtime on all of those machines. Using JMS for the machines that are covered under the advanced features, you can ask it to install or remove versions of Java. So say you were in this example that I had before, you could go and say, OK, in all of these machines that are using 1706, first check to make sure that it's not just that they have it installed, but they're actually using it. And if so, install 1707 and remove 1706. Right? When you're doing the installation, there's an extra option, which is post-installation configurations. There's certain things that you can do that are preset. So it is common when you install a version of the JDK that it will overwrite previous settings. Right? And you might want to give you an example, we're saying we plan to disable, we're not saying this right now, but in the future, we plan to disable TLS 1.3 in favor of some other algorithm. And we plan to do this in 2 years. You could say, yeah, I want that sooner. So you could tell JMS, install the version that is current today, and then go and disable this algorithm before Oracle does, because I want to get my systems at a higher level of scrutiny. So there's a set of pre-configured actions that will disable algorithms or increase key length sizes, or in the case of Linux, you can also tell it, rather than using the root certificates that come with the JDK, let me instead rely on the root certificates that come with the operating system, because that's some people want that. So all of that could be done centrally from JMS for all of your managed instances. And here's what it looks like. You can select versions of the JDK. Before you delete it, you can see who's using it, and you can install new versions. You can install the current versions, which will be highlighted on the top. If you must, you can also install some older versions. You'll get a little warning saying, you probably shouldn't be using that one, but you got a good reason, go for it. So that's all that I have for you today on the existing JMS features. But that's not the end of the features for JMS. JMS is a cloud service. So it moves much faster than the JDK. So if you thought 6 months was pretty rapid, the next set of features of JMS is always, at most, a couple of months away. So before you have another one of these events, we will have added new capability to JMS. So we invite you to keep an eye on the JMS documentation. And if you want to try JMS, the easy way to do it is go to Live Labs. OK, I got to confess, the URL for Live Labs is really bad. But if you go to your search engine and type Oracle Live Labs, it's probably the top hit. And then in the search bar, if you type JMS, you'll get these 3 Live Labs. Perhaps by the time you do it, there will be 4 or 5. The first one, or actually I think it's the middle one of those, will handhold you through the whole process of creating your OCI account, configuring it correctly, downloading the agent if you're going to run it on-premise or in some third-party cloud, or turning it on, because if it's in OCI, you don't have to do that part. It's already into the images that are used by default. So give it a try. Now, if you're going to try the basic features, have at it. Anybody can do it. There's no restriction. If you want to try the advanced features, if you are a customer, again, have at it. If you're not a customer, the easy way to try it is run the workloads in OCI. Remember that I mentioned that OCI is already covered? So if you do not have any, if you're not a subscriber yet and don't have workloads in OCI, just take advantage of the 30 days, $300 credit that you get in OCI, put some trial workload in there, and you can try the advanced features there at no cost to you. If you are an OCI subscriber or are running in OCI, and you need extra help, more than you can get on these workshops, the support team is not there just to support problems in the Java runtime. They can also help you set it up. So reach out to them, and they'll help you configure agents and get it up and running. Now, I hope you go and try JMS, and let us know if you want any new features. As I said, we want feedback. We deliver these much more rapidly than any other feature in the JDK.